All right, so we're going to continue on with our similarity unit, and today we're going to talk about similarity in right triangles. Now, in my past specifically, I struggled with this topic, and it wasn't until I became a teacher until I actually figured out a good way to remember how to do this. And that's the way I'm going to show you all today. And I think when you see what I'm going to do, I think you'll like what I've got for you because it makes life really easy. Okay, so before we even get into the new stuff, I wanted to take a minute or two to review what it means to simplify a square root because that's going to come up quite a bit today. Okay, and so the reason we have to know how to do this is because when you take the square root of a number, like for instance the square root of 40, you get some big nasty decimal. Well, I don't want to do that. So we have to simplify the square root and leave it in simplest radical form, okay? Because this answer is not pretty. I want to leave the square root answer in there. So what we do, and by the way, if you don't know if the square root's perfect, like if you don't know this will be a nice pretty number, just type in the calculator. If you get some big nasty decimal, you're going to have to do what I'm getting ready to show you. So hopefully you remember this from last year when you were freshmen and you learned data and measurement when you learned this. You have to do a factor tree on 40. Remember we did factor trees in middle school? All right, and we need to think of numbers that we can multiply together to get to 40. So I first thought of 4 and 10. Most people start at 2 and work their way down. You can do that, but I just went with 4 and 10. All right. Now, remember, factor trees, you're doing it in prime numbers. So you're trying to get down to all the prime numbers that's possible. Prime numbers mean that you can only use one and that number to get there, to multiply to get there, okay? And so, like on 4, we know that 2 and 2 gets us to 4. And 2 is a prime number. Okay? And then on 10, we know it's 2 and 5. Okay? And then when you get down to all prime numbers like I've got here, you stop. You can't factor any farther. And so now for a square root, what we need to do is we need to pair up our prime numbers. So anybody that you see has a pair, we're going to pair them up. So I see a pair of 2's right here. And then there's no more pairs, so I'm going to quit. So now I'm going to go back to my square root, and instead of 40, I'm going to put any pairs I found are going to come outside and get to go play outside. So I had a pair of 2's. They get to come out. And I had a 2 and a 5 left over that I couldn't do anything with. They're going to stay inside, and you're going to multiply them together. Okay? And another thing, if you had more than one pair out here in the front, you would multiply those together as well. All right, so we had to multiply 2 and 5, so 2. That is the simplified radical of square root of 40. It's 2 square roots of 10. All right, let's look at 90. So 90, what can I multiply to get there? I first thought of 9 and 10. 9 I know is 3 and 3. And then 10 again is 2 and 5. So I've got all my primes. I see a pair of 3's. So that pair of 3 comes outside. I don't have any more pairs. I have a 2 and a 5 left over. They will be multiplied back together and they will give me the 10. So that 10 is going to go back inside. Okay? That's a quick review on how to simplify a square root. Now let's talk about geometric mean. So you probably know the word mean. but in a different context. Mean is we usually call it the average, where you add up all the numbers and divide by how many there are. You've done that before. That's actually called the arithmetic mean. A geometric mean is a little bit different. So for any two positive numbers, a and b, the geometric mean of a and b is the positive number x, such that, and we write a proportion to set this up. So if x is the geometric mean, we say a over x equals x over b. If we cross multiply, we can say x times x, remember, is x squared equals ab. And so x would be the square root of ab. Okay? This is the key right here. We're going to use this. So you can set it up, go here, go here. All right, find the geometric mean of 4 and 18. So geometric mean, we just call it x or whatever. So 4 over x equals x over 18. Cross multiply. X squared equals 18 times 4, which is 72. Then you'll take your square roots. So let me do that. And then x equals square root 72. So now when you get to this point, let's see if that's going to be nice and perfect for us. So you type it in. To get to the square root symbol, you have to hit the blue second key, and then this x squared button right here. Then type in 72, hit enter. I get a big nasty decimal. So that means I have to do this process with 72. All right. So 72, start a factor tree. Let's see. I did 8 and 9. 8 times 9 is 72. 8 is 4 and 2. I can put another 4. Notice how when I had 8, I broke it down to 4 and 2. I could break 4 down again, and so I broke it down. You got to keep breaking your numbers down until you only end up with primes. All right, 9 breaks down to 3 and 3. So once again, we need to look for pairs of our prime numbers. So I see a pair of 2s and a pair of 3s. Okay, all your pairs have to go outside. Okay. And some kids get confused when they do this. Like they want to put, let me put my square root symbol because I know it's coming back. They want to put 2 separate 2's on the outside and multiply them. That's not what you need to do. Okay, don't ever do that. Remember, think about it this way. A pair is 2 separate items, 2 separate things. I said that wrong. A pair is 2 of one thing, right? A pair of socks, you have 2 socks, but it's still a sock. So we're going to put one of the 2's out and the other pair of 3, so we have 1 3. And those are multiplied together. And did we have any leftovers? We have a leftover 2, so that stays inside. And now we'll multiply 2 times 3. So we can say that x is 6 square root of 2. That is the geometric mean between those two numbers. All right, same thing, but for 15 and 20. So 15 over the mean equals the mean over 20. Cross multiply. X squared is 15 times 20, which is 300. So x will be the square root of 300. So now we'll do a factor tree with 300. So I started at 30 and 10 because I know 30 times 10 gets me 300. 10 goes to 2 and 5. 30, that's 6 times 5. And 6 is 3 and 2. So we still need to look for pairs. And so far, my pairs have been close together based on how I broke them down, but they're not always going to be that way, like in this problem. See, I have 2 5s right here, so I'm going to circle them knowing that that is one single pair, okay? And I see a pair of 2s, so I'm going to put a little box around them. That's another pair. Remember, pairs come outside. So you had a pair of 2s multiplied with a pair of 5s. Put your square root. Are there any leftover prime numbers? So ones towards the end of your branches. So we have a 3 left over, so 3 goes back in. And we can multiply that. So x equals 10 squared is 3. All right. Now we're getting into the actual right triangle part. So we're going to have 3 separate cases that we have to look at. And before we look at those cases, I want to give you this diagram of all the possible information that you could see from the right triangle. And so what I've done is I've given you a diagram of one big right triangle, and I've drawn the altitude, and altitude is just a fancy word for the height. So this segment right here would be how tall the triangle is, okay? We call it the altitude. I've drawn an altitude from the right angle all the way down. And the big theorem here that I'm not really kind of explicitly talking about, but we're kind of looking at it, is that this altitude divides the right triangle, the big one, into 3 separate similar triangles. So we've got this small triangle right here. We could call it JKM. That's one triangle. We've got the triangle KML. That's kind of like a medium-sized triangle. Then we've got JKL, which is the big right triangle. All 3 of those are similar to each other. What we're doing is just exploring the relationships between them, okay? Now this is my special way to remember all this, okay? So we put all this weird stuff in here. Of course, this is the altitude, so we label it altitude, ALT. And then I'm going to call this piece right here from J to M, that is leg 1. Okay? Because it is a leg. Remember, in a right triangle, a leg is any piece of the triangle that's not the hypotenuse. The hypotenuse being the side across from 90. All right? So JM, we're calling it leg 1. LM, we're going to call leg 2, because that's a leg in the medium triangle. All right? JK is going to be hypotenuse number 1, or hype 1. KL is hypotenuse number 2, because it's the hypotenuse of the medium-sized triangle. And then we have to look at this entire side, JL. We're going to call that the big hypotenuse. So big hype. Okay? And we call that the big hypotenuse because it's the hypotenuse of the big triangle. All right. Now, our three separate cases, you won't have all that information at once. You'll have pieces of it. So I'm going to show you what the pieces are going to look like and how we set up the proportion to solve. All right. So case number one, you'll have leg one, leg two, and the altitude. You might have something else over here, but if you know what the altitude is, that's when you need to use this specific case, okay? So let's make a note of that. We'll only use it when we know the altitude. If we don't know what the altitude is, we really can't use it. All right. Now, how will we set up to solve it? Because you might need to find this piece, or this piece, or this piece. So here's what you set up. You put leg one over the altitude equals the altitude over leg two. Okay? In this instance, the altitude is kind of acting like the geometric mean of those two sides, okay? Case number two, we're going to know leg one, we're going to know height one, and then we'll know the big height. Okay? How do we set up a proportion to solve any of this? So we'll start with leg one over height one equals height one over big height. All right. Case three is really similar to case two, except you're going to know what leg two is and what height two is. And then you'll also know big height. And so the only difference is instead of one, you'll have the two. Okay? So the idea on all these problems is you have to figure out which case you have and then use the appropriate proportion to solve it. Okay? So looking at this problem, I know this little piece, I know that whole length, so that might make me think I want to use case two or case three. But notice that X is written on the altitude, that dashed line right there. That means we have to use case one all the way up here. So this is a case one problem. And I find it helpful to write the case out and then write out what you're supposed to set up. So leg one over the altitude equals altitude over leg two. Now remember, leg one is always shorter than leg two. So this part's 9. Now, leg two is supposed to be over here, but I don't know it. That's why they gave you the whole length. So you can do 25 subtract 9 to get what this piece is. And if you do that, you end up at 16. Now we know every piece, so we're going to set this up. 9 over x equals x over 16. Do your cross multiply. x squared equals 9 times 16, which is 144. Take your square root. X is supposed to be square root of 144, which equals 12. Most of the time, your answers on these kind of problems are actually going to be nice and pretty, but you could in practice or real life see a square root answer. Okay, that's the next one. So I don't know the altitude anymore. I don't know its length, or they didn't tell me it was x, so I can't use case 1. So it's got to be case 2 or 3. And so I noticed that I know leg 1 because that's a shorter piece, and then the hypotenuse over it, I know it too. That's hype 1, so I know I have to use case 2. So I need to know leg 1 over hype 1 equals hype 1 over the big hypotenuse. And so I know every piece. I know leg 1, hype 1 I got to find, and I know big hype. So 36 over x equals x over 100. Cross multiply. X squared equals 36 times 100, which is 3600. Take your square root, so x is going to be the square root of 3600. And if you type that in the calculator, you end up getting 60, which is nice and pretty. 60, there we go. Okay. Now, sometimes your triangle's not going to be turned it's not going to be turned like this example every time. So what you might need to do is flip your triangle around so that it's written in the way that you know it, that you're used to with the big height being flat. But either way, so let's look at this again. We know leg 1, so this is leg 1. This is hype 1 because it's the little hypotenuse across from 36. And I know it's the hypotenuse because that's 90, so that means this is 90. And then 60 is across from that, so that makes that hype 1. Okay? And I'm trying to find the big hypotenuse. And so this is a case 2 problem. So leg 1 over hype 1 equals hype 1 over the big hypotenuse. And so we'll fill everything in. 36 over 60 equals 60 over x. Cross multiply. 36x equals 60 times 60, which is 3600. Divide 36, you get x to be 100. That's more of a simpler problem. When you're trying to find the piece that goes here, that's where you have to do the square root thing, but otherwise it's pretty simple. All right, last one. Notice we have the altitude given to us, so this is a case 1 problem. And so that's, remember from your notes, that says leg 1 over the altitude is the altitude over leg 2. Leg 1 is shorter, so this is leg 1. We know the altitude. We're trying to find leg 2. So 36 over 48 equals 48 over x. Cross multiply. 36x equals 48 times 48 is 2304. Divide 36. X ends up being 64. All right, that's all we have. So make sure you watch this video in its entirety before you start on your homework. Your homework problems are about, I think there's 15 of them. There's 6 of them where you're asked to find the geometric mean between two numbers, and then the rest are like these triangle problems. As always, if you need help, let me know.